Hello everyone. Today I will present to us my end-of-the-year project in cybersecurity at Holberton School. For this project we were three to working. I was with Solomon William and William Granger. They are students at Holberton at Laval School, and with me Nicolas Messino. Before I start, I will explain to us what is a honeypot. Honeypot is like a trap. It's a fake template or website or a server where you can access, and it's made for attackers, and we remote all action of the attackers. Project information. In this project, we have set up a Ubuntu server on DigitalOcean where we deployed a range of honeypots to simulate attacks. We are concentrated on 4 ports: SSH for a remote server, HTTP and HTTPS for a website, and SMTP for email functionality. We have to choose to create a second server to centralize the logs if the ones was broken, and we have to send the logs, and we can access to the logs on the second server. In this project, we have to use a lot of technologies. At left, as you can see, we have the technologies environments we use. We use UGTLDCN to create our server. We're working on Kali environment, and we use Bash script, Bash languages. And Teapot is a framework we had to deploy the honeypot. All of the honeypots are containerized in Docker, and Elastic, Logstash, and Kibana are the technology used to collect, centralize logs, and visualizing with Kibana the honeypot. And we use Python to create our honeypot on our protocol. Now I will be talking to you about the architecture of an honeypot. When the attackers connect to the IP, our IP, I show IP later, he meets the first network firewall on DigitalOcean, and he had to access in-house server, but we have to whitelist with FW and security SSHD firewall in the server. Because our IP are whitelist, we have access to an admin panel, but we open the port for the honeypot. We open the 422, 443, 587, and 80, and all attacks was made on the honeypot are sending in the remote logging server. Now I will show you a little demonstration. Now, as you can see, that's the dashboard of the honeypot. It's in the last one day. We have 80,000 attack. I will create an attack. For example, here, just before start, I will show to you our IP. Okay, this is the campus IP, 82. Now I will try to connect to the honeypot on the port 22 server. As you can see, I didn't have the access, but because Nicolas is not whitelist. But I can try with, for example, John or root, but I will do with John. And now I have the access of the fake shell. It's a fake shell created by Corey in the port 22. I can do what I want. I have access to the file, but that's a fake file. And as you can see, I return on the dashboard. Just I change the filters. In 1 minute, we have 20 attacks, and we have our IP here. We have orange. And here I have the identity connection, username Nicolas, password Nicolas, and John I use to connect. I have the localization of the people who want to connect. And I have the same result in our second server. I do regret because it's very ugly, but now you can see the connection. I try Nicolas, and the duration of the connection 8 seconds. Okay, now I will talking to you about the config file of the Cori and the Mylony honeypot. That's a YAML file, and as you can see, we are on the file. We have the name of the container, we have the ports he used, for example, 22 and 23, and the volumes is the path we need to use to have the logs. And for example, Mylony, we didn't use the 25 port because DigitalOcean didn't want to use, because we have the new accounts we need to pay. That's why we use the 587 port. Okay, for the timeline, the first week we have to create the first server on DigitalOcean, where we set up the UFW DigitalOcean firewall and the SSH config on the server, and we deploy Typotc framework too. In the second week, we have to set up and analyze the logs of SSH, HTTP, and SNTP just on the dashboard Kibana, because we have the dashboard when we create the Typotc. And the third week, we have to create our honeypot on the port for free HTTPS, and we can manipulate the log as I showed to you on the Docker container. And the fourth week, that's when we create the second container, when we send the logs with Logstash. It was the technology we used. And the last week, we have to report the attack simulation and prepare the presentation. Okay, if you want to update our project, we need to add more detail logs to capture full session data, header, and upload content to better analysis. And the template we used for HTTP and HTTPS honeypot are not very realistic, but we need to update that for the attackers. And in the third project, we want to deploy more of honeypots on more protocols. Thanks for watching. I say the IP if you want, you can connect and try to hack us.
Is a fake server easy to hack to attract hackers, to let them try to hack you, and if I understood well, the finality, the goal is to see how they do that,
yes.
Which commands they type,
yes.
and so on.
That's right.
So with the data you have, like yesterday you had 18,000 attacks.
Yes.
From this data, what can you conclude? Do you have any hints on how they did it? I'm not sure to understand what is the purpose of this.
Yes, if you want, we have an example. One night, a guy had to do a brute force attack. Mm-hmm. He made, I have the picture if you want.
Sure.
Here, the guys make, with the 77 IP, he makes 73 attacks in just 2 hours. We have the CPU info, but we didn't analyze all of the inputs he make.
Okay, so
you want to know the inputs?
No, not
okay,
really,
okay.
But I'm trying to understand what's the purpose. So from this attack, you can see that he will try brute force a lot of times.
Yes.
And so what would be the answer to give to protect the server?
To protect the server, we just need to, with the firewall I said before, we just have to block his IP, and we can knowing the IP, but probably it's a VPN because I think it was in Poland. That's why, but we can block his IP to the server.
Okay. So maybe an action would be if the count of requests from an IP is higher than, let's say, 1,000, we block this IP.
Yes, and we have already we have an identification we can see in the logs, and we can already block the ID.
Okay. Okay, I understand it. Thank you.
Thank you for your presentation. All the data see on Kibana are real attacks, or it's fake data?
We think it's fake. I have an example of a real attacks. We can see that the guy is doing on the server. You want to see? Okay. Here we have to make the attacks. The guy is connected on the server with the SSH key, encryption key, and he used the username root and password root. It's a regular utilization. But before, when it was in the server, he tried this command IP cloud print. He wanted to know if the server was a MikroTik router OS, but he had a command not found. That's because it's a SSH server. Later, he tried ifconfig. That's to know information about IP addresses, network setup. But the IP is not saved. He have a fake IP. When you do this command. Later, it try uname. Uname it's to know more information about the system. Later, he want to know the CPU information, but we have just one CPU for the SSH server because we did not need a lot of CPU. He want to know if it was mining, if he mining crypto money in our server with a PS-grep miner commands. And he wants to try SMS phishing. He wants to know if it was a GSM or if the computer was connected as a USB. And later he understand it was a honeypot, and he say to us hi. And he closed his session. He was staying 63 seconds on the server. That's we think it was a real guy.
Okay. And do you reference your server or your IP somewhere, or?
No, we didn't. No, we didn't.
You will try a lot of IP address.
No, we have just references his IP.
Okay.
And we can see he was a blacklist DNS.
Okay.
You were free in the project.
Yes.
So you didn't do that on your own alone. What did you do on all you presented? What was your part?
My part. For this project, we are working in peer. It's Alberton ID. Every day we have to make video conferences for 4 hours in the afternoon, and one people show his computer, and we help him to code the honeypot. We have to do all every time we have together.
Okay. Each of the three did the whole project.
Yes.
The entire. Okay.
Yes.
So there was no kind of teamwork, like you do this part and you do this part, and.
Sometimes we do that. We have to deploy. For example, I have to deploy more the server, and the guys more one honeypots. Sometimes at the weekends, but in the week we working together.
Okay. And for you, what would be the next step if you would like to deploy this to real companies, for example?
I think we need to understand how to block the guys, and we need to update the honeypot. No more honeypot on the dashboard. And if we want to update just the templates for the web server.
Okay, thank you.
No more questions for me. That's okay.
Okay. No more questions? I think that's it.
Okay.
Okay, so hi. Today I'm going to present you my video game, Runner VR. So first I'm going to introduce myself. My name is Camille Favriel. I'm 25 years old and I'm in the virtual reality specialization at Alberton School. So about my game, it's, if you know the game Subway Surfer, it's based on this game. So it's simply a game when you need to avoid obstacles and try to get the biggest score possible. So for the main features, you have the physical interactions, which means that you can move using your controllers or using your own body to move to the left or to the right. You have a dynamic obstacle system, which means that the obstacles are generated randomly every time. So you get a different level every time. You have procedural generation, which means that the game generates himself every time, following specified rules. And you have, and so of course it's an endless game, which means that you can keep going as long as you don't crash into an obstacle. So for the tools that I've used, I used Unity, which is a game engine to develop a video game. I used GitHub to keep track of my change. And I used, as a programming language, I used C#, which is the programming language used with Unity. So for the timeline, for the first week, I focused on the basic mechanics, which includes the movements, and I started to work on the infinite generation. On the second week, I focused on the obstacle and the collisions. On the third week, I focused on the user interface and the visual of the game by adding different 3D models. And on the fourth week, I focused on the score tracking and optimization of the game. So for the demo, the game doesn't look centered in the demo, but it is with the headset. So you can choose between two locomotion modes, two movements, and set up the sound. And so as you can see, you can jump using the controllers, go to the right, slide by using your own body. And I'm going to advance a little. And so as you can see in the settings, I'm choosing the physic locomotion mode, which means that it allows me to use my own body to move between the lanes. And as you can see, the score is saved in the leaderboard to try to get better every time. So how does it work? When the game starts, it generates random chunks, which means it generates the road and the buildings that you see. It then generates the obstacle and coins and places them on the chunks directly. Then it moves the chunks to the player, so the player is not moving. The world is moving to the player. It updates the score and coins, and it checks if the game is over, if the player crashed into an obstacle. So how does it work? It's my code snippet for my main function, which generates the obstacle on the chunks. So first, it checks the lanes and rows, the emplacement available on the road. It picks a valid obstacle. So by that, I mean that it checks if there is, for example, 3 vehicles. So if there is 3 vehicles, it's going to delete one to allow the user to have an available lane. And then it instantiates the obstacle on the chunks. So what's next? I would like to include an online leaderboard for more purpose. I would like to add more 3D model, so more environments and vehicles. I would like to add achievements, better user interface, of course, and adding bonus like the ability to fly on top of the car for a few seconds, for example, like on Subway Surfer, and improve the movements, make them smoother, and have a better graphics as well. So what I've learned to design a runner in virtual reality, but it could work with a mobile or even a computer. I learned to handle the movements in virtual reality. I learned also to generate an infinite world and to make the game, like I said, available on multiple devices. For the challenges, the hard part was to find good assets, good 3D models that are free to use, which is not simple. And the second challenge was the planification, which I think I didn't do enough, so I met a lot of problems that I could have possibly avoided. So thank you for listening to me, and that's it for my presentation.
Okay, thank you for
If you have any question. Yeah.
Oh no.
I will have a few questions. First, when you use your own body, how do you change it from lane to another?
By moving to the left or to the right.
Your real
Yeah.
position, and how long should the step be to move from a lane to another? If you move just a little bit, you don't change?
Well, it works using the position of the headset.
Mm-hmm.
So it detects if you do a little movement, on the left or the right.
Yeah.
And it detects it. You only have to do a small movement.
Okay.
You don't have to. Yeah.
A very little one will never be confused as a.
For now, it could.
It could.
I think. Yeah.
And you do that and.
Maybe not, but more that or.
Okay.
Maybe. Yeah.
Regarding the coins generation, you never have coins on lanes with obstacle, like you would like to go there, but then you hit a vehicle. Can this happen, to have coins and just after an obstacle? But because on the demo, it looks like the coins are only on the good way.
No. It's supposed to be able to spawn everywhere.
Okay.
But just not in an obstacle.
Yeah.
But of course,
you could have a bait.
Yep.
And, I want to go there, but I lose because just after there is an obstacle.
It could happen as well.
And can you quickly change from the lane if you go to one with an obstacle but a coin, and
Yep.
then?
Yeah, you can.
Okay.
You can do it. Yeah.
So it's not really a bait, which is good. The way you construct your map, is it like an array and everything is regularly processed, or is it like real coordinates? Here it looks like discrete coordinates, like in an
Yep.
array, 1, 2, 3, and so on. It comes with regularity, but
So
maybe it's not like that.
no. So basically, it uses the coordinates,
Mm-hmm.
and so it spawns 12 chunks. So
Yes.
12 segments in front of the player,
Okay.
and every time 3 segments goes, not 3 segments. Every time a segment goes behind the player at a certain position, a coordinate, it destroys and spawns new chunks in front.
Okay. Does it go quicker and quicker?
Yep. The more further you go in the game, and the more speed you get.
Okay.
So, yeah.
Okay, thank you. I have one question. What was the most complicated and time-consuming part of this project?
The infinite generation.
Okay.
Because every time I modified something, it was breaking the game every time.
Okay.
So because you need to handle the obstacle and the movement of the road. So if you move the world faster, the obstacles are going to spawn not at the good emplacement. So you need to handle that And yeah, the biggest part was infinite generation.
So it's really a problem about gaming program, not really VR program. It's not a problem about reality, virtual reality.
Yeah.
It's a problem about gaming and all game.
Yep.
I think all game have this problem. That's true, or do you think?
I don't really know. I mean, it's a problem that I could have avoided
Okay.
by using a completely different approach from the beginning.
Okay.
So I wasn't able to, at the end, to switch
Okay.
my process.
No more question for me, but
Could this game be uploaded on Steam, for example, or do you think you still have a few things to add?
For now it's. I think I have a lot more to add, especially the movements. For now, I'm using teleportation, which is not smooth. I would like to have more smoother movements. I would like to use better assets, better looking assets, and I would, like I said, use a completely different approach to be able to make the vehicles rush to the player. To make it more realistic.
Okay, so
Yep.
because right now everything is static.
Yep.
And you would like some vehicle to be
It's more dynamic. Yep.
Okay,
Yep.
okay. Yeah, it could be more fun like this. Maybe a simple question. Did you enjoy coding this game?
I have learned a lot.
That's not the question.
I have learned a lot, but I wouldn't say that. I think I thought the idea. I thought the idea of the game was good, but it's not perfect for now. It's far from. No, it's my idea.
Yeah,
but
okay. But still, you don't like this too much.
I mean, I would, like I said, do things really very differently.
I see. Yeah, maybe it didn't require VR for this game. I'm not sure, but what does using VR for this game add compared to not using it?
The movements. The movement.
Yes. Okay. Okay. Well, that's it for me too. Thank you.
Thank you.
Hello everyone, hello to the viewer of Fréjus. My name is Cédric Chauvet. I'm a machine learning student in Alberton School. And I'm here to present to you my portfolio application. It's called SafeCook. SafeCook because it's an alimentary application, and it corresponds to the eating habit of the users, and give some recipes about, for instance, a vegetarian or somebody which has an allergy. And you simply take a photography of your fridge, for instance, and the model detect all the all the elements, and it will give you some recipes in order to cook your meal. So we can try the app if you want, if you are ready. So you can see in the screen, this is the landing page, it's the home page. So first of all, you can select your habit, your eating habit. This acts like a filter and give you the recipes which are free allergens or free arachide or free lactose. There is, it's much like for the test, but we have a playlist of some recipes that are stored into the database. So I work a lot on the design of the application. It's not perfect, but you can scroll to select your recipes. And for instance, if you like quiche, you can access to it, and you have the ingredients and the steps to cook it. Okay, and if you really like it, you can like it like this. So just one. You have also the rating of Marmiton. So this one is 4.5 stars. And we scrapped also the time of preparation of the meal. Okay, so we have this, but what is innovative is because there's a lot of things with LLMs. We saw at television that there are LLMs that make that prepare that help to prepare some very good restaurant meals. Okay, and here you can take a photo of an apple. And the model detects it. So he counts one apple, the allergies, okay? So allergies is not filtered in this version, but it is in the last one. And it gives you some recipes that are selected for you, like beignet aux pommes, très facile. Okay, so you can see here there is some apples, so everything's fine, it works. Okay, so I wanted to show you more, but as I say, it's an early version, and it's like a proof of concept for the moment. Okay, come back to the presentation. So, how does it work? This project is based with front end and the back end architecture. The front is in the mobile phone. Okay, so when we take a photo, it's sent through the web, through the host, to the host machine, an image, and this image goes through the Docker container and is handled by the YOLO model, which is a detection object model. When the elements are detected, it goes through the database, and the database will select the good recipes, and they are sent back to the mobile in a JSON file, in a JSON format file. One thing which is very important too is the dataset, because it's well known that the bigger data you have, the better will be the model performance. So in order to train our model, I gathered, sometimes manually, sometimes automatically, 6,000 of annotated element items based on 6 items, apple, orange, bananas, potatoes, salad, and tomatoes. So it's still under work. And something important, what? Okay. So, which is not the sentence, which is not, I don't know why, maybe, yeah. So the data set must be balanced in order to the model will have no preference for an item or for another. So we have 6,000 apples, 6,000 tomatoes, etc. Here is some reliable website in order to gather images. So maybe you know Kaggle, which is well known in machine learning, but there is also Robot Universe, which is very interesting for the dataset. And I used to open image on the bottom, which is an API, Google API. So I gathered all this data, and now we have to put them to train the model. For the mandatory code snippet, I choose the hyperparameters. So, in fact, you have a model, YOLO, and when you train it, you have several parameters you have to choose. They are called hyperparameters. So, you can see there is plenty of them. And the game, the goal is to choose them right. And this led to me making a lot of experiences with different hyperparameters in order to give the model the best. We can see here, it's a monitoring tool called TensorBoard, and there is the performance of 3 models. You can see in different metrics, so the metrics is the evaluation of the performance. And we can see that the gray one is slightly better, okay? So these 3 experiments are based on the optimizers. So I tested 3 optimizers, and I choose the best one, which is Adam standard, which is the gray one here. So it's like that, we make from a lambda model a good model. We have to make many experiments. And there is every time good and false detection. So when it's good, it's okay, it works. The model works and the application is operational. But there are 2 kinds of false detections to avoid. It's the picture has a banana, but it's not boxed, so it's a false negative detection. Or the object is detected, but it's not a good class. So this is a false positive detection. So we have to keep the true detection and avoid the false positive and the false negative detection. That's the goal. So, in a global overview, we can see the technology used for this project. So I work on the Visual Studio IDE, which is very helpful to work. It proposes many options, and it's handle Python very well. For the organization, in order to discuss with the SWE or the mentors, we use Slack or Discord, so we can keep in contact with the mentors. GitHub for the versioning, which is mandatory at Alberton. Using a Trello in order to make a timeline, we can see next the timeline. ChatGPT, which helped me a lot. For the machine learning part, it's essentially based on Python language. TensorBoard, which is a submodule of TensorFlow. Ultralytics, which is the model of YOLO. So it's a module, and you can use YOLO with this module. And then for annotation, handmade annotation, I use a website which is called Computer Vision Annotated Annotation Tool. For the side of front end, I discovered React Native for the mobile phone, which is very close to JavaScript, very, very close. And the Expo, how can I say, Expo give you will compile the code into the mobile phone. Okay, so you can have for development the application on the mobile phone, and not like how can I say, Android Studio, which is a window on the computer. Here it's directly on the mobile phone regarding to Explore. Okay. And for the backend, Docker, Google Cloud, which is for it's. I put the container inside Google Cloud, and I can access it like with an URL. And it's accessible anytime. The server is always open. There is MongoDB, which is new for me, and it works for the recipes. It works very well. And MongoDB Compass, which allows you to have a graphical interface for the database. So my favorite part is the timeline. I had a lot of time to develop this application. Because it's the second time I present it, and I can divide it in 4 parts. So the first part, it's to think, to define the objectives, to choose the tools, the technologies, and to make a plan. On the second part, we can set up for example, the Expo framework. We can set up Docker. We can set up MongoDB. You can. I began to scrap the data and made some tests. The third part is like the skeleton, the architecture of the code of the application, and the fourth part is to ensure that the data are well displayed on the mobile phone, that the YOLO model give correct results, and make it happen. I had to fix some bugs. A blue screen of death during the training of YOLO, which was very hot. And the fine-tuning, so the fine-tuning of the YOLO model. And it leads to proof of concept that the demo you saw just before. I learned a lot on this project, especially in full stack, because I had no skills on front side, and I didn't know React Native. So I learned it, and I liked it. And it's led me to try the front end and the right design of the application, the design application. And it was very interesting to start from scratch to a proof of concept. For the side of machine learning, I think to go further into YOLO was very interesting, and we discussed a lot with the three, the mentors, and especially it's a very easy to use, and we can make a very beautiful thing with YOLO. And as a conclusion for the experiment, that 1000 annotation can give good results in order to detect some class of object. So thank you for your attention, and special thanks for Manuton. And if you have any question, I'm open.
I will start. Thank you for your presentation. I have two questions. The first one is, YOLO is the best model for image detection, or do you try with other models before choosing YOLO?
Yes, it's a good question. There are several types of models, and YOLO is an object detection model. So it detects the object, and it's boxing it. Not all the models do that, but it's not mandatory to localize the object. So there might be other models like VGA or faster RCNN, something like this, that could do the job. But I like YOLO, so I choose it. Just I didn't. Yes. I thought, oh, that will be great, and let's go.
Okay. And the second one is, why did you start from developing front-end parts and not machine learning parts? Because on your timeline, you say you have 4 parts, and the machine learning one is at the end.
Yeah.
Why do you start with front end?
Yes.
Because if you start with front end, you can do a lot of works, and at the end, the machine learning won't work.
That's true. That's true. I started with the front end, and I think I wanted to have the application, and then to announce the model.
Okay.
Because I think for presentation, the appearance is important, and maybe if I took more time to work on the model, maybe I could present maybe 6 or 8 different elements, and that would be very good. But there is still a lot of work, yes. And for the performance, we are about maybe 90% of a true positive, okay. And so my mentor told me, it would be better 98. So there is a lot of work, but yes, we could do differently.
Okay. That's good for me.
That's it. So thank you for your presentation. Regarding the parameters, have you tried different learning rates, for example?
Yes.
And which one was the most?
So for Adam has been selected.
Mm-hmm.
So there is two different learning rates, and it has been discussed with the mentors, which is I say a lot of 0.001 and 0.0001. So what I did is to train to 0.001 and then make 20 epochs with a lighter, smaller learning rate, yeah, in order to find this minima of the loss.
Okay, that
yes.
was my second question. How many epochs did you have to do to
I tried 100 epochs.
Okay, so the 80 first epoch are with the first learning rate?
No, 100 and then 20.
Ah, okay.
Yes. But I did it manually. Just I learned the model, and I took it in another file and put it 20 epochs more because there is other way, but this one was easy to do.
I'm quite surprised that you need that much epochs for just 6 classes.
Mm-hmm.
And so the total number of images you fine-tune on is 36,000, if I understood well.
Can you repeat, please?
You have 600 images for bananas, for apples, and so on. So the total is 36,000?
Not really. It's 6,000 annotations. So if there is 3 apple in a picture, it would be counted as 3. But we are around 1,500 photos. But the protocol, the framework we use is to train to a light data set, maybe 1,000 of annotation on 3 elements, which are apple, oranges, and bananas. Make the experiment, and find the good hyperparameters, and then put it in a bigger data set, and that gives good correlation. Yes.
I'm not sure to understand what you do with the images that are not annotated.
There are few, but maybe I'm wrong, but I think an image which is not annotated in yellow is considered like a background. I'm not sure, but I think it's like this. So I'm not sure because I think almost the image are annotated, and I didn't chase the pictures.
Can you go back to your slide where you said 6,000 images?
Here.
Yes. So you have you collected 6,000 annotated images.
Yeah.
So that means they were already annotated?
Yes, because
and you added 1,000 images that you annotated yourself?
No.
No? I don't understand.
It's pretty simple. So those are the websites to gather the maximum of annotation.
Yes.
Image and annotation. And I made 3 folders where I put all the images for each class, so many images. And then I wrote a script for myscript.py, my class, my number of annotation, and by this way I could I managed to make 1,000 annotation, 2,000 annotation, 6,000 annotation, and then you put it in the YAML config of YOLO, and you only have to say, so I want you to work in the 1,000 annotation folder. And so there are a lot of gigabytes of image by this method.
Okay, so you trained on subsets of.
Yes.
Oh, okay.
Yes, and it's randomly choose a subset of a big database.
And that's why you conclude that 1,000 is enough, because
Yeah.
you tried with 2,000, with 3,000.
Absolutely.
And only with 1,000 it was already good.
Yes.
Results.
Yes.
And when you say good, I don't remember anywhere on the presentation quantitative results. Like I have 99% of good recognition or something like that. Do you have this kind of results?
I can, yes, somewhere. Let me duplicate it if I need. So it's not the. we can see many things. So something like this is very interesting.
Yeah,
And this one is a 1000 annotated result. And I will zoom it because if you are not okay, it's readable. Okay, so this is like an heat map, and you have the detected object and the truth detected object. So you can see a dark diagonal, and that means that there is true positive. Okay, and this is maybe a false positive, and this will be the false negative. So as I say, I am around 90%.
Exactly.
Which is very
background tasks, as I see.
yes. And there are something, but I can't show you. There is a kind of an artifact because with the bananas, a bunch of banana is detected or annotated like one banana. And when you took in a photography a bunch of banana, maybe the model will detect 2, 3, 4 bananas. And this affects the loss. And you can see this one, banana background. So this one is biased.
Yeah.
Yes. And so Malek, my mentor, told me to make this to make a monitoring for the loss of each task to see what kind of what are the tasks that are well detected and the tasks where it will need more work.
Okay, very good. Regarding Expo, you said Expo was used to directly on your smartphone the application.
Yes.
I've already heard of Expo, but I thought Expo was a way to develop on the language JavaScript and then export to any device, iOS, Android, and so on.
Yes, so it's Expogo. Expogo, because you make an Expo project, okay? So on this project can work in OS, iOS, Android.
So your project could work also on iOS, Android, and so on?
Yes, but without Expogo.
Okay.
But no. I'm not sure that the library of the photography of the camera is the same for iOS, for instance.
Okay.
So I'm not sure the instruction of this mobile work with an Apple one. I'm not sure.
Okay.
But
that's a little tweak with React Native to just
yeah.
If iOS then do this, if Android then do this.
Yes.
That's three line, I think.
Okay. Just one last question. Have you tried training with only fine-tuning with only 10, 20 epochs and no more? Because you only have 3 classes.
Mm-hmm.
They have really different colors. Maybe it didn't really need machine learning for this because orange are orange, apples are green, and banana are yellow.
Yes.
Just mean colors on the image and it could work.
Yes.
So
Yes.
I'm very surprised that it requires 100 epochs
Yes.
to be trained.
I think the training is not stable enough at early epochs. I think.
Okay.
You can see here there is a mess here. There is a mess.
We don't see much on this. Yeah, it's oscillating a lot.
Yes, so one is better, on the next epoch it's falling, on the other one is climbing.
Isn't it just that the learning rate is too high and so it's oscillating like that and maybe with a shorter runtime?
Maybe
something like that.
it's a good idea.
Okay, that's it for me. Thank you very much for